So here's the easiest type of problem using Pythagoras' theorem, where we need to find the hypotenuse. Here's an example. What's the longest length of an iron rod which can be placed on a 3 metre by 2 metre floor in a garden shed? So if it's going to be on the floor, the longest rod we're going to have is the one which goes diagonally. So the first thing we should do is draw a diagram. Here it is, 3 metres by 2 metres, this outside of the shed. Now I've only done half of the diagram really, because that's all that we need. The longest rod then that'll be able to be placed in there is this one, which would fit diagonally like so. Now we can label the sides of the shed using appropriate letters. Maybe we can call this side A, this side B, and then we're going to find the hypotenuse C. So there it is. We see we've got a right angled triangle of sides 2, 3, and we want to find the hypotenuse. Now to set out the answer to this, we should first start with a statement of Pythagoras' theorem in symbols. There it is. The square on the hypotenuse is the sum of the squares on the other two sides. Then we substitute what we know. A is 2, B is 3. So we know C squared is 2 squared plus 3 squared. No need to reach for a calculator for that one. We can simplify in our head. 2 squared is 4, 3 squared is 9. So C squared is 4 plus 9, which is 13. And we know to solve this, if I take the square root of the left-hand side, I'll get C. I must take the square root of the right-hand side then, and therefore C is the square root of 13. Now that's the exact answer, square root of 13. The square root of 13 is a decimal number. It's actually a decimal number that will never end. And if we're trying to find the length of rod, we should really give it in a meaningful number as a decimal number. So if you do that on your calculator, you'll find C is that number. And as I said, it continues on. But to round it off to a sensible accuracy, well, for a shed like that, probably to the nearest centimetre is going to be near enough. So this is in metres, 3 metres. The first two decimal places then are centimetres. So if I'm running to round this off to 2 decimal places, I look at the third one. It's 5 or above, so I'm going to round this one up to 1. The 2 decimal places, C is 3.61 metres. Just another point here. Actually, C squared equals 13 has 2 answers. They're actually plus or minus the square root of 13. But because C is representing a length, it can't be negative, so we ignore this one. Just another little thing to help you with the setting out. If I reveal this little thing here, I call the way I've set this out the 5F method. First F for figure. I've drawn a figure which represents the situation we're talking about. I've put the facts, the figures that have been given to us on the diagram. Next thing, I've stated a formula. The formula in this case is Pythagoras' theorem. Then this working out here is finding the answer. And lastly, fix it. I mean by that rounding it off to a sensible accuracy and putting in appropriate units. 5F method is a good thing to use in questions like this, and of course questions like measurement.